Dear audience online, I'm very happy to welcome you to the newest edition of the ITU Network Spotlight. It's the third event we have after the summer pause, and today we have a very up-to-date topic, a very recent topic, which is web search. And when I was younger, when people were talking about web search, it was basically web search was equivalent to Google. Yeah, Google had like a market share way beyond 90%, and in order to discuss how AI and technology can potentially change even this relatively monolithic field of web search, this is something we will learn about today, and this is something we will hear about today. And just to give you like a personal anecdote about that, when I was recapping that I heard, I think Google is predicted to lose a certain type of market share even more than we have observed in the recent month, up to 25% of traditional web search. Then I tried to recall, where did I actually find that? And I don't know, 2 years ago I would have gone to Google searching that, but what I did instead was talking to an AI chat, like a language model, and basically circumventing a classical Google search in order to get my information. So how this will develop in the future, and also which consequences our user behavior, but also the technological development of this will evolve, and how we connect that to terms of legal aspects, economic aspects, etc., is a field of high interest, both scientifically but also economically. So I'm very happy that we have one of our ITU experts in that field here with us. It's one of our fellow professors, Michael Granitzer, and he will guide us in the next about 60 minutes to go deeper into that field. And then afterwards, we'll have questions, a discussion on the topic. So I'd like to invite you to give a warm applause to our guest and have fun with the lecture.
Thank you very much for the very nice introduction, and also hello and welcome from my side. When I was starting my studying and did web search, it was not Google, it was Alta Vista and Yahoo that I still used, and there was a young company called Google who took over at some point in time. So it's quite interesting to have worked in this field for this amount of time, and to see how this field developed. And now with the rise of LLMs and chatbots, there was this question, what will happen to search? And so I thought about, I will talk today a little bit about the future of web search, what I think, what we can expect, what the trends are, and also based on a project I did for the past 3.5 years, which occupied most of my time, called OpenWebSearch, which is a European funded project that tried to bring web search back home to Europe, so to say. So what will I talk about? I have a bit of a mix between technical and non-technical things. If I'm too technical, Stephanie knows that very well, that I can sometimes go down in this rabbit hole very, 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 very fast. Please interrupt me and I go out again. But I try to cover different aspects that will touch societal aspects, that will touch legal aspects, also economic aspects, but of course tech, because I'm core computer scientist. And I will start with today's web search ecosystem, reflecting a bit how we search information today. Then I want to go down this tech rabbit hole a bit to outline how a web search engine is actually built, what are the ingredients and what are challenges in there. Also because I think it's important to understand how LLMs will change or will not change web search per se, and what we can expect from the ecosystem. Because as you pointed out, Google will lose market shares in advertisement, maybe, but they might gain it somewhere else. And then I want to briefly discuss OpenWebSearch, that's so to say my European project, and on what we plan to do or what we have done, and conclude with the future. So let's a bit critically reflect today's situation in web search. And if you look web search, I can ask the question, who did Google today? Who used Google today? A few people. Who used ChatGPT today? Yeah, okay. So to be expected. So web search is an essential ingredient for navigating the digital sphere, and without it, we would be lost. It's comparable to satellite navigation in the physical sphere, which we also require to find our ways. And so it is the case with web search. However, there are two properties that do not fit up. First, that it is this kind of critical infrastructure. And second, that it is a market oligopoly. That means it is dominated by a few players. One could even say it's a monopoly for Europe. And you see that on the right-hand figure, which gives us the market shares of search engine companies. Now, a lot of people say, yeah, there are a lot of different search engines out there, which is like Ecosia or DuckDuckGo or Quant. But they are all using the same tech. This is just the front end towards most often Bing indices or Google indices. So the underlying search is done by those companies. And of course, one could say, well, basically, we are controlled, or the information is controlled by a few gatekeeper, but it's free of charge. We do not have to pay for it. There's money. We pay in other things. So it's a good service. Does it matter? And I want to, from my perspective, say, yes, it does matter. Because compare the situation as if you would have only one newspaper all over Europe, where you get your daily information. Nobody would be happy with that kind of media landscape, or? And so there is a lot of power in having a single interface to information. There's a theoretical study that analyzed the effect called the search engine manipulation effect that has shown that the ranking in search engines can impact voter behavior in the range of 20 to 80%, depending on demographic groups. So that's quite a lot, and gives you a lot of, one could think that this is not the best way if this is controlled by one. Also, secondly, the web itself is a very rich source of information. So it contains not only web pages, but it also contains a lot of structured data. So products that are listed. There are, for example, shops, web shops, opening hours. You have even scientific information there, medical information that is integrated into web pages. You can find lists of courses, so educational courses or data sets. And of course, if you're blind to this information source, it's hard to track for you disinformation or misinformation. You don't know where the source, where an information artifact originated from. Yeah? It's hard to track different actors, and it makes you blind in this sphere. And here you see all certain examples of applications that actually exploit data that is in the web, either GDELT, which aggregates events, product shops, or even maps applications that tell you when something is open and when something is not open. I will later on have examples on that a little bit more to see how one could exploit that. It also matters because Europe as a continent is not present in the web. And how can I say that? There is a nice study from a person called Martin André. He wrote a book, Big Tech muss weg. Very critical book. He is a media and communication scientist. And what he did in his PhD is he analyzed how much attention German people pay to certain websites in million hours. And what you can see here on this chart is basically the ranking of the website according to how much hours are spent on that website and the hours on the y-axis. And if you now say there is no curve there, well, there is a curve. First is YouTube, second is Apple, third is Facebook, fourth WhatsApp, fifth Google, sixth Amazon, seventh eBay. It was 2020, so TikTok is not there, and that's the rest. So there you find Süddeutsche Zeitung, Spiegel, and all these famous German news outlets, you find them there. And they are basically non-existing in the digital sphere because it's dominated by 1 to 10. And that's critical, yeah? Especially if you think about how revenues changed in the web. So this is a chart that tells you revenues in analog or digital sphere and in the time. And you see that in 2020, we had a break-even point, 50-50. And it's expected that in 2029, we will have 25% analog revenues in media, so advertisements, etc., and 75% digital. And now if you consider that with this chart here, you know where the money is going. So that's why it's relevant. And finally, one can also say, yeah, but now there is AI, and AI changes everything because we will have large language models. But still, even if you are engaging in AI, either in training language models or training AI itself, you need data. And the web data is still one of the richest sources in this regard. That is acknowledged by a number of companies, and it's a critical resource ingredient for training large language models. However, beyond using the data for training large language models, you also saw that, that's actually an older slide set I reused from a meeting in June in Brussels, that it was quite new that suddenly you could also search in Claude and in ChatGPT web search. So they did web search, integrated the results to add a context there. And that was quite a new feature. But now it's imminent. Now the tools, the chatbots are searching to enrich their context, to make information more recent, to make information more controlled, and to reduce hallucination. And that is where current language models are, in that sense, happening. So as a conclusion of this motivation, one could argue, so if web data and web search matters, then Europe needs to have its own web index and web search engine to navigate the web. So that would be one conclusion, and I will pick that up after a slight excursus into what are the challenges in building such a web search engine, what is the impact of generative AI in that regard, and I also will mix in a few of my own results that I did with my team. Yeah. So building a web search engine is simple. You have 3 simple steps that you follow. The first step is that you have to crawl the web. So meaning you write a robot that navigates the web pages and, so to say, clicks the links. But you need to do that at a very big scale, and I will have some numbers for you later on. Then the second step is also an offline phase. You're building the index. So you have a set of documents. You're creating the index like in a book, a little bit more complicated. And then you're getting such a kind of index, and then you're ready to deploy online services that then do the actual searching. So what you usually have is a query. You get the top 10 result out of the index. You rank them accordingly, and you show the results to the user. So that is the basic steps. But in every step, there is a lot of technology involved. There's a complex tech stack that you need to navigate. And I want to go into these individual steps and highlight those challenges a little bit further. Plus, in the context that these web search engines are already established, then there are also some challenges that stem from the ecosystem that are hard to navigate, which I also want to highlight. So before we go to these individual steps, the question is, what is this kind of a web index? Computer scientist, one can define it as a data structure for fast access to web documents that supports search, filtering, and ranking. So to get this kind of list. And today we basically have, in such a web search engine, 3 kinds of indices. One is what is known as a sparse index that can be compared to the index you find in a book. So that means you have all words that are, or relevant words that are listed in the book, and it points you to the page where this word is occurring. That's exactly what is shown here on the right side top, which is a kind of term list and the posting list that you use. You usually calculate some statistics over that, how often does a word occur in total, in how many documents does a word occur, and how long is a document, to create some statistic, and from this you can get a good ranking, under quotes. In the early days of web search engine, this was the primary mechanism, but then when people have found out that it's easy to spam, you just write a lot of words into a web page, and then you always appear at the top. So that was search engine optimization 1.0. That's also where Google's PageRank came into play, because they found out that if you exploit the link structure in the web, you can get a better ranking, basically. And that brings me to the second index, which is a kind of feature index. So you collect different other signals in order to improve the ranking. One signal could be this link structure, but other signals could be also the linguistic structure of a web page, the genre, additional metadata that is in there, or how this web page is used. so the usage of the web page, and this brings us then to search query logs and the whole privacy debate we had. What is now coming is the so-called dense index. That's the newest stage in web search. That is basically an index that is a vector, a set of numbers, usually 1,000, that semantically describe the content of the page. It's usually created via language models, smaller ones that are there. And it is a better way for representing the semantics of a page, if you want to put it that way. So this is the index. I will come back to the which index is used for ranking a little bit later on. So now we know what we want to build. Now is the question, how do we go there? And these are the 3 steps. Step 1 is about collecting, so to say, the web pages. And that's so crawling the web. And that's basically a solved problem, nearly a solved problem. The biggest problem you have is efficiency. Yeah? So you always have to trade off. The web is huge. It's a huge, messy place, and you find everything there. And most things you find there you do not want to have, except for very special cases, like if you're a criminal investigator or whatsoever. So it's always a question to balance completeness and freshness of what you have in the data set with the resources given at hand. And so a rough number to give you an idea how much you need in order to keep a complete and fresh index is that you roughly have to crawl 100 million URLs per hour. And then you can keep up with recent news, like that PayPal now offers, teams up with OpenAI for offering a wallet in ChatGPT, and to get that in there. Yeah. There are strategies how to get that, but that's the rough and basic number. Of course, there are different, from a computer science perspective, different strategies. You can go breadth first, so you're finding a page, you find all the links, and then you traverse all the outlinks of the page. And if all of those traverse, you're going to the next pages. You can go depth first, where you simply take a page and then you go to the next page, and from that to the next page, and then to the next page is another strategy. Or you try to prioritize that somehow by saying, okay, I don't navigate ads, but I want to navigate other stuff. That's an interesting part. Again, here, machine learning and AI plays a role. We had a cooperation with colleagues from Italy who showed that you can also, again, use large language models, not large, small language models, for finding good next steps without knowing the link structure. And this is from the paper. The figure is from the paper of them. But anyhow, it's more or less a technical challenge. However, it's also an ecosystem challenge. You usually have certain protocols and rules that you have to adhere to. These are the so-called politeness rules. And one very important is the robots.txt. And that lists which agents are allowed to crawl a web page and which are not allowed to crawl a web page. But that's more a recommendation of the website owner. You cannot enforce that. And so what happens is that people simply ignore that. I just had yesterday an email where somebody told me, yeah, you know, there is all kind of crappy software that crawls our web page, and I only allow with certain IPs, so please give me your IP of your crawler so that you are allowed to crawl our web page. And there is a clear benefit then for the people who already crawl, like Google and ChatGPT, that they get access to content that is usually not accessible for others who also aim to crawl. So there is a clear locked-in point there. Also, certain high-end websites like LinkedIn, YouTube, Google, Amazon do not allow you to crawl them. You can pay Microsoft for getting the content and use it, but you cannot crawl it. You are not legally allowed to. So there is a kind of ecosystem challenge there that the winners are taking all. Yeah? Also, the web is a highly competitive adversarial environment. So if you start crawling, you end up in what is known as crawler traps. So these are structures that try to trap your crawler and send it into infinity loops so that you always get the same page but under a different URL, so that the content of them is spammed. So that's the first part when you start building a web search engine. The second step is also a complicated one, that is If you have the data, you have to clean it, because nobody wants to work with this messy HTML data. So what you usually have to do is you have to extract text out of it, maybe extract images. You have to extract metadata, which can be a very rich source for a lot of application scenarios. You might encounter web pages that have JavaScript. You have to run them and do them. And you have usually very different formats, not only HTML, but also documents, PDFs, etc. And if you have done that, you can do a lot of cool stuff with that. Yeah? But that all costs resources. So you can geotag. You can identify all web pages that talk about lints, or have talked about lints, which you usually can't. Can try to extract knowledge graph or something similar. The biggest issue is that everything here needs to run at scale. That means this 100 million URLs that you collect per hour needs also to be processed in that hour. Otherwise, you're just getting a backlog that is not workable. So you cannot, I have sometimes students who say, yeah, let's do language model on that and let's extract the semantic information on that. No, you can't. Yeah, you would. There is not so much compute that you could do that at this scale. So this is one technical challenge still, and getting the data right is, data cleaning is always messy. However, there is also an ecosystem challenge there, because if you look how Google solved that problem, we all think they did a smart job, have the smartest brains, they did some smart algorithms to do that. No, they invented search engine optimization. They gave clear rules on how people should optimize their websites. They gave them a free tool called the Google Search Console, where you can look up how much traffic you have on the website, how your website is represented, etc. So they basically crowdsourced or outsourced this problem to all others in the ecosystem in order to optimize the index for them. So they provide the tools. However, on the bright side, this also resulted into a lot of structured data. And I referred to that several times now. What does it mean, structured data? If you have a website, then usually the website is created from a database that you have. Either if you have a web shop, you have products in there, or if you put your impressum there, you can also put your geospatial location and your address there. So, and this is not only there in form of text, but also in the form of metadata. So if you go to the Google page, search for structured data, or if you search for microformat, microdata, you get clear descriptions how you embed this information in your web page. And so if you ever wondered how Google knows how many reviews and how many stars a certain web page got in a review page, it's not because they have a smart algorithm, but because this metadata is based off the web page. Similar for FAQs. That is also, for example, what we did and where we exploited that. Here on the right side, you see such a FAQ page. For the non-tech people, that's not HTML, that's just a JSON data format. It's just metadata that is embedded there. And what we did with the web data we crawled is we extracted these FAQ pages, so frequently answered question pages. We scraped roughly 96 million questions in 1-2 weeks. And had question and answer pairs for 75 languages, which then is a nice resource for train or fine-tune an LLM on that, because you have a very rich and very accurate source. You also encounter these FAQ pages every day if you search for Google. That is, if you have these kind of questions that are answered, one can think these are smart AI summaries or precursors. They are not. They are just structured metadata that is given by the web page itself. And so this is a very rich source. You can find courses in there, course lists, data sets, job posting, products, local businesses, etc., which allow you to exploit that. Now, if we have our index and if we have processed everything, we can think about how does the search process actually work. And this is, let's say, not Alta Vista, but maybe Google 2010 search process, how they did it. What you basically have is you have your query that you put in there. You usually have a query, and there is also a profile associated, most often with browsers or users. If you have a Google account and you logged in, there's for sure profile information that they use. The first stage is then that there is a query analysis, so people want to identify what information intent do you have, what query intent do you have, what do you actually want? Do you want to search for the next place? Do you want to to get some information? Do you want to have an exploratory search because you are unknown about a certain topic? And this is what is used to derive the original query, and that goes in the process that is called the first stage retrieval process. And this uses both indices, the feature index and the sparse index, to get you a very big list, so roughly 1,000, 2,000 results. That's the initial list, and this list goes into the second stage, which is then a re-ranking stage, and there you have already had, since 2010, machine learning algorithms that basically learned on click-through logs, on past experience of you or other users, what web pages to put on top and what web pages to put on the bottom. So this comes from search logs. It's learned, it's machine learning based, and that gives you then the top 10. And the top 10 are then ranked as a list. And then there's a whole bunch of advertisement that comes in because some people bid it for some places there. And then you add a little bit of advertisement there, and that's how the search process worked. And this part here, the learning to rank, is essential for getting a good search. So you need to have usage data. Otherwise, you end up with so many irrelevant pages from the user's perspective that you cannot deliver a good search service. And that's hard to get. One thing we did from the research perspective in that regard is the question on, can we simulate users? So can we take a minimum amount of logs, try to learn how users behave, identify different user groups and different profiles, and then simulate this information retrieval process in order to evaluate search engines. What we did is, well, we developed extended an existing simulator framework called SimIR from Live Azubadi, that is Glasgow. And that is based on a model on how people search that is called the complex searcher model. And there are different models out there. There are, for example, information foraging models, so going to hunt for information. But this is a very nice one. It's also very simple. It's basically you have a topic in mind, you generate the query, you issue the query, you get the research result page back, you examine the pages, then you decide if you're happy with one result or not. If you're not happy, you can either go to the next result or you can basically issue the next query, and so you iterate the query. And you can download documents, and you can basically then also mark documents. And this is the process we try to simulate. There have been, on the user side, different ways for steering the behavior of the user, mostly rule-based decisions on how users behave. Yeah, some users take the first result, some take the second, some take the third. And what we did there is we had user logs, and we tried to learn stochastic models, Markov models that approximate user behavior from these logs to then see whether we could simulate such a user behavior, and we identified different kinds of user groups. For example, user groups that are more exploratory, user groups that are more picking on certain known items, and could successfully simulate users. And then came LLMs. So completely whole story. We don't need search anymore because LLMs take over, and there is no need for retrieval. But that in turn turned out to be wrong, because basically what is now the predominant pattern for doing search, not only in the web, but also in other circumstances. For example, at the university in Passau, we have also a chatbot that that is working for the IT support, gives you answers to IT questions, that is also based on this retrieval augmented generation pattern. That means the generative part of an LLM is augmented with retrieved results. Those retrieved results are basically providing context to a model, and the model is then integrating these results into its decision-making process. And from a technical perspective, so that's the user endpoint, the user just has a chat, as the user expects, with a lot of text and nice to chat with. And what changes on the technical side is now that instead of a query, you have a chat, which is not 3 to 10 keywords, but a longer sentence that can be very strange or very precise, or you find everything in natural language there. And what you now need to do is to somehow understand this language and derive queries from that. First approaches when ChatGPT came out by Microsoft, by Bing, is that they simply converted the chat into a set of keywords and then did the search. That did not work so very well because the sparse index could not contain the information of keywords very, very nicely. And so what has been developed are so-called dense indices. These are the vectors. So you convert basically the natural language into a big number string, and then you search this dense index. And the rest stays basically the same. Yeah? You get the top K results. You have to re-rank them. You use search logs and the machine learning system. Now it's no longer old machine learning. Now it's new fancy transformer technology that also boosts LLMs. And you get, again, top 10 results, because if you have more than top 10, your context window explodes, and the LLM cannot work with more than top 10 results. And then you go into the LLM, give it the results, and the LLM summarizes again. That is basically the predominant pattern that is happening in RAG applications. Now you can say to yourself, okay, that's an iterative process, because I search, then I have a new question, I re-answer that question, I reiterate, I search again. So search is repetitive. And I think you all know that, yeah? You learn something a bit about this web page is not what I want the other one. And so it's a natural step to then think, okay, we can go the next step and simply let the LLM completely search it. We are just interested in a complete result, and let it do these iterative cycles more and more and more. And that is now what is called agentic AI, at least for search, or agentic AI-based search. And if you look at it, it's basically that you have an API that abstracts the whole process of searching down there, which is exposed via a protocol that is, now it's model context protocol, or OpenAI specification is also possible, but MCP is currently taking over as a protocol that seems to become the new standard. You still have under the hood the same things, like sparse index, dense index, feature index, top K, re-ranking, transformers, a user profile, you get the top 10, and you give it back. However, what you now can also do, and I will show that it really works, is you can also use an LLM to interpret the user profile. So you can write down the user profile, what are your preferences, what is your emotional state, are you happy with results, or are you anxious today, and are you want to go more deeper or more narrower, or more broader. And you can use that in order to improve the results. And you have the AI agent who runs the searches several times, aggregates the results, makes a synthesis of the results, gives you a table, and that is basically deep research, how it is done by OpenAI. This is also how we approach the SimIR, the simulator that we have developed. And this is now the next iteration step of the simulator. Remember, I told you that we have this rule-based system for modeling users. One way was to completely replace that by LLMs. So you use LLMs in order to model your user base. This was done by Laif Azzubadi. He went from Glasgow to Microsoft during that period. And we also have added what is known as cognitive state, so trying to model the cognitive state of a user, because that could impact somehow the search quality. And we also modeled the cognitive state as a simple stochastic process. So what is the probability that when you click the third link that you are in a that you want deeper information or not deep information, but also in that sense as an LLM. And don't worry, I'll give you an example in a minute later on. And on the other hand, we also started to ask the question, what if we use this agent as a conversational search agent? How do agents behave if they are exposed to such a search scenario and such a search interface? Do they behave like users, or can we make them to behave like users, or do they do something completely different? And this is also a big question currently in the industry. I had the DAX-Tool report, a DAX-Tool workshop a few weeks ago, where we exactly discussed how agents will search in the future. and how their behavior will be different, or how their capabilities are different and resulting in different search behavior. Anyhow, yeah, these are the points. To give an example, the first question we asked is, can LLMs simulate real users? Remember, I told you these are all LLM agents. So for those who don't know, an agent is nothing else than a different prompt on an LLM. That is usually what we do. And the question is, do they behave like real users? And this is an example of such a search sessions. We had, the goal was to find simulation studies on open access effects in economics. Then the LLM thoughts was more on the factual things. So we want to have, the last queries was on open access and economics and citation advantage. The click-through rate was low. The emotional memory is also coming out of these modules, was then saying that the frustration was high with broad terms, and that the profile was more on depth and recency of information. And these have been the chain of thought promptings of the LLMs. And then it came out with the action. That means the action was a formulated query, open access, citation advantage, economics, with some filters that we apply, 2020, source ecombis, and there should be a parallel query opened because it searched two queries in once. Yeah? So this is an example of one search process that has been conducted by an LLM. And then we looked how similar, for example, the queries are that are issued, and compared different queries. That was this agent 4DL, that was the LLM that did the queries. And this has been other methods, like popular selection, is that you simply take popular queries from the search logs from other users. Random selection was to take any query. And the discriminative selection also had the kind of stochastic bias towards certain parts. And we see that the overlap and the similarity between the queries have been highest for the agent that we trained. And so one could conclude, weakly conclude, that the queries that the agent did are quite comparable to human queries, yeah, and that it queried correctly. Now, if you have a thing that basically can simulate something, you can also use the same thing to improve something. And so that was then the next question, whether if we don't use the LLMs for simulating search, can we use it for improving search? And what we then did, we developed PersonaRAG, that is, again, agents that imposter different personas and model different parts of cognitive processes. For example, we had the user profile agent that thinks about, given a certain query, given the results, what is the user profile telling me what the user wants to have? Or a contextual retrieval engine that tries to look back in the session and say, okay, what was the context of the query from before? A live session agent that looks more at the short-term relationships, a document ranking agent that is just concerned with ranking things, and a feedback agent. And they have been communicated by a global message pool, which is nothing more than, again, text prompt, where every of these agents wrote what they thought about the search process from their different perspective. And we then used another prompt in chain of thought prompting to select, select that and come up with a correct answer because we selected the correct context. Okay? So I saw you laughing. PhD came to me, told me, yeah, we do that. And I was also laughing and saying, yeah, sure. And that should work. We use LLM now for everything. Yeah. But he then had an evaluation that showed that compared to other different search methods on 3 different data sets, this whole PersonaRAG always performed best. Yeah. I would say it's not the best evaluation. It's not the most robust evaluation. I would criticize there are no standard deviations whatsoever. But it also took us very long to run this process because one search took a minute or so. Yeah. But it doesn't matter if it took a minute or not, because the models will be optimized to run faster and more efficient. It just shows you the potential on 2 things. First, that we get better. And second, how easy it is to model that. If I go back to my previous slide here, developing these modules, the heuristics and the tools and the statistical models, it was quite complicated. Yeah, a PhD had to spend a lot of time in modeling those. This was writing a prompt. Yeah. And this shows also how powerful that is and how we advance. Okay, the question that is open still is, do we need a big model for that? Do we need something like ChatGPT 5.0 or Claude for doing that? Or can we find smaller models? Smaller models that are particularly focused on this task of information retrieval. And just an hour ago, found a paper on small language models and how they will run this agentic world. And I strongly believe that is true, that smaller language models that are focused on a task will outperform larger language models that try to do everything. So specialists beat generalists. You can count me wrong. And the paper I showed before was 2024, and we would have been happy. Yeah. Forerunners, we do something with agentic AI, and it will take some time until it hits industry. Okay, this was this week. I think most of you know that OpenAI released the Atlas browser, which is an agentic browser. So in the browser, there are agents that analyze what you do, what you want, how you are. They can even control your cursor. If you see the promotion video, you see that the cursor is floating around, and under the cursor, you see what the model is thinking about what to do. The human is still in the loop, which means the human can still steer the process, but you know, it's like with self-driving cars, yeah? Oh, it drives alone. God, I watched the movie, yeah? So basically, yeah, you will let the agent do and simply from a certain point in time and trust the agent. And one interesting question I asked myself is, why did they build a separate browser? Because you could use the same tech in a standard browser. Not the same tech, but it would be harder, but I think you can. And the risk I see in this development is that there is a new kind of gatekeeper appearing. The gatekeeper is that we no longer browse the web, but that we simply go into the web via a chatbot, and that we consume everything via the chatbot, and we don't know what is the truth behind that, or what is the source, not the truth, the source behind that. And then I asked ChatGPT, because I'm very bad in reading terms of use, so I'm not a lawyer, and I asked that what the terms of use should summarize it with this respect, and then ChatGPT told me that itself in the Atlas browser that there is a likelihood for a lock-in and monopolization, because they can steer you, they capture rich behavioral data, they steer you with defaults and promos. Of course, they tell you you can opt out, but in reality, you never opt out because this is hidden somewhere in the 7th menu, and that they are able to mediate the web through this AI. So there is a risk that I see that is coming up. Plus, there was an announcement today, just when I come to Linz, I read it on TechCrunch, that now PayPal wallet will be available in ChatGPT. That means this browser who is going to shopping for you can also pay for you. The good thing is, I think, advertisements will be gone, yeah? Because the companies will pay OpenAI directly to sell to the corresponding product shops. Yeah? So, joke aside, I think that is a serious thing we should think about, how information spaces will evolve over the time, and also how we position ourselves as a continent, as Europe. And that brings me to the last part of the talk, and usually, unfortunately, spend always too much time in the first part, so I have to rush through this second part. But this is OpenWebSearch.eu. That's now a project that started 2022. I'm coordinating that. It has 14 partners, and the goal is to build an open index of the web and use correspondingly an open infrastructure and a transparent tech stack for doing so. And the thinking of us back then, 22, was, okay, the one thing that Google will never ever open up, never. They make all source code and software and everything open, but they will never open up their index. They will never give you access to the raw data that they have. And this is what we wanted to change. So we had 4 objectives. We wanted to develop an open technology stack. We wanted to develop because you need a lot of resources for that stuff. Yeah? So we wanted to create a network of infrastructure partners, because Europe has strong infrastructure units. They just need to be coordinated properly. We wanted to show that such an open index has added value services, so there are use cases that can be done. And we also wanted to show that we can bootstrap an ecosystem around this open web index to exploit it for very different things. Who are we? That have been 14 partners, researchers, mostly from the field of information retrieval with the Davis Group. It's, I think, would say the strongest information retrieval group in Germany. Radboud University with R in the Fries, TU Graz, and the German Aerospace Center. These are NGOs that are interested in opening and keeping the web open. There was one business partner, quite unusual for a European project, but we had one. They developed the business plan. And we had a set of infrastructure partners like LAZ, so that's in Munich, the Leibniz Rechenzentrum. CSC, it's not very well known, but they have for years been coordinated, leading the consortium on the European biggest supercomputer, LUMI. It's now standing in Jülich, but it will be going back to Helsinki soon. And IT4I, which is a Czech partner, also part of this Euro-HPC network. And of course, CERN, and this also fulfilled a lifetime dream of mine. So I did a project at CERN with CERN, not in physics, but in computer science. That's cool to see. Good. What did we do? As I said, we tried to develop this index, which is basically what it requires is to develop a kind of web data infrastructure that runs across these data centers, which has these individual steps. And the goal was to go from the web, which is in exabytes, to an index that is more manageable in the petabyte range, and also have the raw data available to then foil, and I'm running quickly over this slide because that then basically goes into 3 scenarios. One is AI research and development. So give European or give people data for training the LLM stuff. AI-based search, what I showed before with LLMs, vector embeddings, etc. And also web data analytics, because there are a lot of analytical scenarios still there that are interesting to do and very important to do. And I will have some use cases later on. So that's the vision. Where are we now? The project will be ending in February, but everybody is eager to continue, and we hope we get the funding to continue. So if somebody is here with money, I would be happy to take it. No, just joking. So we have currently 25 machines crawling in 4 data centers, and we are currently expanding that. So for example, we just recently added Oldenburg as a data center, which is a smaller university data center, but they still provided some resources. We added them, and we are now also crawling there. There is one central crawler coordination queue at CSC or CERN, and we crawl roughly 100 million URLs per day. So that means we are a factor 25 away from a commercial search engine. Still, I'm not sure if the quality is already up there, that they're good enough for that. And we also respect very different technical limitations. We also have been very early in adopting so-called Gen AI opt-out protocols, where website owners can say, I want that my content is not used for generative AI. Caveat, it's the same problem as with robots.txt. The crawler do not need to consider that. But there is now a recent advancement, Cloudflare, which is a provider for protecting websites from different security attacks like DDoS. They are now, they saw the business model. They are now basically blocking all crawlers from LLMs and from agents until the website owner allows it. And that means the website owner can also go there and say they have to pay. So which hints towards a new business model for content owners. That's where we are. That's just our technical setup. Don't go much into detail there due to time. We also did some experiments on question, can we filter good versus bad content early? And so one idea was, because it's a costly process to do that for every page that you crawled, to filter that, and you also want to know before you go to a web page that the content is good or not. So we played around with machine learning on the URLs. So just having the URLs, what can tell me the URL about the quality of the content? And we developed a data set for that with malicious, benign, and adult content in these different categories with some subcategories. And we did an experiment where we showed that, okay, you can use this URL classifier to quite achieve, at least on this data set, quite good results for filtering out good versus bad content, even better than if you take the whole HTML into account. So technically that's feasible. Legally, don't do it. Yeah, don't do that. Because we also have the ethics and the legal group. The problem is, as soon as you identify that you potentially have illegal content there, you have to investigate that. Yeah, and so yes, a lot of times I spent discussing with our legal teams. So that is potentially problematic, and so it's better to not do that and not knowing that you have illegal content, because yeah. We still do it to a certain degree, so we have blacklists and whitelists, so we are doing that manually, but that doesn't require us to then investigate an uncertain result, yeah, or even inform criminal investigators that you might have illegal content. So that's a bit where tech bridges to legal with a few of implications. Yeah. And that's non-legal advice, so I'm no lawyer. I cannot give that legal. That was my interpretation of what the law people told me. Yeah, as I said, we also analyzed different opt-out protocols at different levels. I don't go into details there. Maybe just the interesting part is we analyzed how opt-out has changed in the recent years from 22 to 23. So we compared this robots.txt file and looked at if a certain AI-related bot is mentioned, how did the blocking of that bot increase, which percentage? One prominent bot is CC bot. Most people don't know it. It's Common Crawl. Common Crawl is a small NGO with a crawl engineer in Germany when they started, who did crawling the web since 2008 or 10 as an open resource. And it was the primary source of information for the first GPT models. So these crawls have been used to train GPT-2 and GPT-3 and even GPT 3.5. And then people started to know that they're crawling for everything, but people associated them with stealing their content. You see that this disallow rate, so blocking that crawler, if it is mentioned in the robots.txt, went from 61% to 99%. So that significantly increased. And also for the other bots, like GPT user, if it is mentioned in the robots.txt, it's blocked. So a lot of people are basically blocking AI-generated content because they see it also a bit as a stealing, I think rightfully, of their intellectual property right. Yeah, what we are also trying to do in the project in order to give more control to website owners is to develop to be fully transparent about our crawling, so what we crawl, when we crawl, and also to give a little bit rebuilding this Google Search Console, giving people the ability to claim their web page and also to add the opt-out. So on the page you can go, you can search for the websites that have been crawled. Sorry, that have been crawled. You can then search for Unipassau here in this example. Then you find our web pages there that have been crawled. You can then go to the details and basically see when we have crawled it, which legal information we have about the website. You can claim ownership and then restrict us, or say this content is for Gen AI, it's none for Gen AI, etc. So that was the first prototype to give more control to webmasters and web owner over our web index. So the other part, in the pre-processing part, we also developed a full OpenStack pipeline for pre-processing HTML content. That was done by the Webis group, Martin Botthast and Benno Stein in Weimar and Kassel, where people can also plug in their own module into that to analyze web data at scale. We do not have a lot of features per se, so we extract language, a bit of topic extraction, and some very limited geolocation, which is basically based on metadata. We can talk about that later on, I'll tell you why. But it's quite open. And so it was interesting to see there was the AGES company association in Austria. They want to protect web shops, for example, in Austria. And they have been interesting, or they are also crawling the web for web shops and analyzing those web shops. And now we're discussing with them whether their web shop classifier could be extended here, that we identify that the web page is a web shop or not a web shop, because they want basically to analyze whether the products in the web shop are safe or not safe, and give you this alignment. So this is one example where one could cooperate or use that kind of data. Now, the last part is this indexing, and we produce daily index charts. So it's a part of an index that we publish daily. On the right side, you see a network analysis of a daily index chart, where you simply visualize groups of links. You will not see a lot. It looks cool. But just to show you also the scale of the index. And yeah, we provide this index for download. It is basically a full text index, but we have no search API yet, so you have to build basically your own search index on top of that. I skipped that experiment. We also have our different use cases that we developed. One is a prototype for RAG-based search, developed by the Technical University of Graz, but also from the DLR, a science search use case where they take parts of our index and augment their own search, which they have internally with web data in order to do that. Good. There are other use cases, just to name a few. For example, with the Joint Research Center, we are also aiming to monitor supply chains of products that are mentioned in the web, and if they are compliant with European regulations, as one use case. Or we have a cooperation with Morena. They provide a smartphone operating system called smartphone operating system without Google, and they want to enrich their map applications with opening hours that are crawled from web pages by us. So these are examples on how this web index can be used. We are currently operating over 3 Euro HPC centers. That's Helsinki, Lumi, IT5 in Czechia, and Munich LAZ. We have CERN there, and we have a network of other partners who provide parts of the infrastructure, and we did the federation layer over those in order to be able to work with all of them. And the vision is, of course, to extend that. The vision is to go larger over Europe, to add more nodes in order to pool resources so that we have similar capabilities than big tech, at least for this kind of parts there. Especially then when it comes to dense indices and using large language models, that's critical. Last part, we also did ethical, legal, and societal analysis of this whole thing, and it was a nightmare. We had 3 legal teams working. They analyzed 50 different legislation. And there are white papers with over 300 of pages that one can read. What we are usually not allowed to do, or what governance procedure we have to do, how many privacy assessments I have to take. And it's painful. It's really, really painful. And the biggest impact currently is copyright law. That is not only for our index here, that also concerns everybody in Europe who trains LLMs. Copyright law is a gray zone. It's a blocking issue that, especially if you go to the commercial side, it's unclear how we deal with that. And a lot of initiatives I know, and I'm in contact with a lot of them, always have the same problem. Are we allowed to use that content for training? And what do we do with the resulting model that comes out? The only way around that currently is take risk. You have to go forward because there is also no legal ruling. There are no court rulings, so you cannot do that. So that's a big step. So now, what are next steps and conclusions? I think, just give me these 2 more minutes. I know I'm over time, sorry for that, but give me these 3 more minutes because I think that is important thoughts. I think we have to think about how future information access will happen. And that is, I strongly believe that LLMs will not replace information access, but they will always need a strong retrieval search engine at the back. And this retrieval engine will be strong if it is focused on particular content that is for a certain domain, curated by human experts, maybe jointly with LLMs, but where we know what's in there, where the information quality is high. And this will not be a web source, or most likely not all of the web, because the web will be polluted with a lot of LLM-generated content. I do not expect that the web in its current form will prevail. I think the entry point will be chatbots in future for information access, and we have to find ways for verifying and validating this information, which brings me back to highly curated information systems. And as I said before, with OpenAI and this Atlas browser, there is currently a risk that if the web vanishes, that there will be Atlas as a browser. And that's our primary information source. And I think we have to compete that. We have to do something else, and that's my idea of having a federated agentic AI-based search systems where you have different parties like that provide information repositories, like CERN is the expert on particle physics. So they should cover all the information about that. There are traveling companies, yeah, they should provide the information, it's okay. Law, you could have a repository there, or for education, you could have different well-curated repositories. And I think that these AI models will become so small that they will be able to run on your device, run in your browser, and that this whole agentic setup could be at your disposal and under your control. But that means not installing Atlas. Okay, I'm a little bit over. But that would be at least the vision that I want to pursue in the futures, if we can achieve these kind of decentralized agentic web search systems with more control over content and more control for the users over their own behavior and what the agent is doing on their behalf. And I skipped the summary. Thank you very much for the attention, and okay, 5 minutes later. And I'm happy for questions.
As typical, I'll suggest we open the floor for questions here now, and for the procedure, do we have a micro for giving around? Perfect. Then who would like to start? I'm pretty sure there's lots of questions.
So you showed the slide where we have a very uneven distribution of users' interest on web pages, right? Like YouTube captures whatever percentage of the attention.
It's attention, yeah.
At the same time, these private companies have an interest not to let people crawl their website, including you, I assume. Yes. So your index, does that incorporate YouTube, for example? Does it incorporate? So what percentage of a usual web request, like a usual Google search, right? What percentage of the click-through rate would be covered? You see the problem, right? Like your index doesn't include.
There are two answers to that. First, we talked to other companies about using the data. They had exactly the same thing. Do you have YouTube? Do you have Amazon? Do you have LinkedIn? Do you have adult content? I said, no, no, no. And then they said, okay, then we don't need it for a commercial web search engine because our users are not interested in that. The point is, if you want to accept that, you can also have an alternative, because I don't think you need all this. You don't need YouTube. You can go to Mastodon. Yeah? You can use other sites and alternative in a web search engine. Of course, most likely a search engine will not be competitive. But there is also, from my perspective, the chance with these new systems, with agents working on that behalf, that they might not require YouTube. They might not require this kind of web content, but maybe other sources that are of higher quality. But it is a problem. You can also pay for it. That's also possible, of course. But we don't have the money.
Hi, thank you. You sort of alluded to that anyway in the slide before the last, that there is sort of like the web of the future is going to be flooded with shit, right? Basically, and the idea of navigating that involves some mechanisms to figure out what is the shit and what is the stuff that you would be interested in, right? And your final idea about these kind of very carefully curated indices that have authority to kind of speak within a particular realm of information, right? That would be obviously extremely nice. But I would also kind of maybe raise the question about gatekeeping there, right? Who are these institutions? With CERN, maybe we all agree, but then, you know, who's speaking for religious questions? Is that the Vatican? Is that our index that we want to kind of refer to? Or, you know, whatever. And this is an age-old problem, right? I mean, it was the problem with newspapers and publishing houses and who has the power to kind of control information and all that. How do you see, like, in your vision of a federated web search, a mechanism for the public to, you know, in the same way that we've done with publishing houses and newspapers, to ensure that it's in public interest?
Well, first thing, yes, I completely agree. It's an age-old problem, and I guess this will not be solved here. But at least you see which repositories are out there, and you might get a chance to look at the agent and know what the system is doing and where the information comes from. So at least provenance problems are somehow solved with that. So that's the first part. And then if you have the provenance problem solved, you can think of different mechanisms. Yeah, like newspapers also have certain ethics, they have certain regulations that you have to apply to. There is a board that controls whether this was done properly or improperly. So I think there are then mechanisms in place. Yeah. And for the first part, I think in this transition period, we are currently also working on methods, what we call authentic web pages, authentic information, in order where we try to find out what in the web is an authentic information. That doesn't necessarily correlate with LLM-generated content or mean LLM-generated content. It just means that maybe a user-generated content with an LLM, but it's genuine information in order to decipher that. But that is a research project that we just applied for.
Very hard questions, right? What
yes.
is authentic and what is genuine? And
yeah,
all
but,
this.
But one idea of this research project is to use crawler telemetry data to identify websites that try to fake you. Because if there is a website that publishes every day hundreds of articles about AI, then it's most likely a website that is either very popular, has a lot of editors, or somebody who tries to bring out information. But these are old problems.
More and more search would be done agentic by agents. What does this change in your idea for the advertising, online advertising agencies in
Good
industry?
Question.
Have you any idea how these agents are interacting with ads, or are they just vanishing?
I personally did not do a lot of research there, but my colleague Martin Botthast from Kassel and the Davis Group from our project, they spent a significant amount of time in what they wanted to do is to identify how this how much advertisement is in generated text. But they found out that they did not have the data, so they went the other route and asked themselves how they could add advertisements to generated text. And one nice example was so, runner ABC ran in shoes, bracket like Nike shoes, they are nice and they are light, bracket closed. Yeah? And so they found out that it's quite easy to on a very subconscious level to place these kind of advertisements in there. Yeah? I think it will be more explicit, so you will get a hyperlink that leads you then to an advertisement placement, or if OpenAI comes out with a browser, you will see just the advertisement all the time on the right side, or maybe it is a different business model. But I'm pretty sure that this will come. Yeah? And detecting that is quite hard.
Going back to the topic of the gatekeepers, do you have written rules about who can become a gatekeeper? And
well, I don't have rules for who became a gatekeeper, but the European Union defined gatekeepers. Funnily, we had that in our proposal. So we said gatekeepers, it always had this minority. But the European Commission came up with explicitly mentioning now Google, Facebook as gatekeepers. And I would see them as mostly hyperscalers that have a lot of users and that mediate access through very small services. And there is a lack of transparency in the back, where you don't know where the information came from, how it is ranked, why you see that in the current place. And the problem I see with big companies, I have nothing against big companies and markets, quite contrary, but the problem is that you see they have a lot of power that they accumulated to steer governance processes. And if you ask yourself how an AI Act came into place, and if you ask yourself whether Google will pay the fine, or whether some politician will say, if they pay the fine, then 100% more, then you see where the power is. Yeah? And I think that is dangerous. Single source and controllable information and a lot of power. And that, in a simple version, would be a gatekeeper.
So linking back to the question from before, technology is always political, by definition, more or less. So on one of your last slides, question before was that when whatever chatbot becomes the entry gate towards the internet, you mentioned that the information that comes back needs to be verified. My question would be, who would be interested in even doing that? Because that's a presumption you're taking there to some degree.
Yeah, it's like the economic human. Yeah? You always assume that people act rationally, yeah? Which is not true. Yeah? That's an assumption I take, which is a very strong bias, I know, because most people won't care to verify the information. But my point is more that if something is transparent, then some people might be clever enough to find tools to convince people about looking, or put a red flag there, or put a white flag there. At least you can do something. If something is coming just via one tool, they have a completely intransparent process in the back. You don't know. Let's compare it. Nobody knows what's in a bottle or in the supermarket of superfood that you buy. Yeah? You trust the system, and there is a label that tells you it's healthy. Yeah? And so you trust the people who gave the label. And the label gives you the opportunity, or some labels, to trace back where it came from. So you have at least the opportunity to go that way. And people who put that label on there can also go back that way because it's transparent. But if there's just a bottle where you cannot have this transparency, I think that is the crucial point.
Why we trust this, that the ingredients are really in the bottle, is because there are laws that state you need to do that. Now, the question would be, aren't we beyond this way of understanding the world? Because this naive understanding that the internet is open and free and transparent was there in the 90s perhaps still, yeah, or in the 80s, but not now, right?
Yeah, I'm still naive, I think. But you're right. The point is also you trust the law. But the question is, can the law be enforced? So can lawmakers oversee that? That's true for the bottle, they can do. But I doubt it's true for such a complex system like ChatGPT, OpenAI, or Google, where they have no clue. Or where it's nearly impossible to understand this. But that's why you're right, maybe I'm too naive, but transparency is still a property that I think holds there.
Yeah, you did just have.
Yeah. I call myself naive in that regard, yeah, for both the user and.
So yeah, thank you. Just one quick question, because I see some parallels, like in the ambition with the OpenWebSearch.eu project to make like something again European-centered and like bring like Europe back like in as a general player. Is it in any way connected with the parallel project of the Central European data spaces? Is there any synergy? Is it just the same movement to make the cloud and the knowledge processing?
Yes and no. We talk to the data spaces people, obviously. Yeah. There will be also currently there will be activities to bring data spaces to AI factories to harvest this kind of data. The point is that the web is not truly, in that sense, a data space, because data spaces interpret them that somebody owns the data and can give licenses and property of the data. And that's completely not true for the web. The second property that is not true is that you find everything in the web. Yeah? And so it's not a particular domain that we're engaging in. But still, we are talking to the people, although we're talking more to the AI factories, but data spaces also go alongside there.
Question for me. Just like, because you showed a short snippet of JSON LD, so RDF data, and some of the stuff, it's sort of forgotten, but are there any traces for you from the whole vision of the semantic web, and this, if you are like familiar with that?
Oh yeah,
specific, like the thing, the technology that never dies.
I spent a
that
lot
never
of
came to life and never died.
years in the semantic web doing that. Yeah, still I think what is remaining are microformats and JSON in the LD, and that picked up. So I think it's roughly 60% of the pages that have that. And I think it's still a valuable information, but I hardly find any ontologies, OWL or something that's not there.
Missing another standard, just.
Yeah, but agents are there now. So the agent vision comes through.
So, if I understood right, you perceive, for example, Atlas searching engine as a hierarchic system, and you propose a more democratic system for the access to information.
Yeah, more or less, yeah.
Okay. What I'm missing is if this is more of a democratic engine to access information. I miss some definitions of the actors of this environment. Which kind of actors are interacting? How can you become a certain actor? What are your possibilities within the processes?
Yeah, sure. I agree that this proposal is not fully fledged out, and I agree that you have to stronger define that, who is an actor or who is not. It's not, I'm more techie guy, so it's not my strong suit to define that. But I think there is a clear differentiation now between the information providers, those who provide content, those who own the content. That's the difference, yeah. Those who use the content, and those services that allow you to consume the content. Yeah? And I think this is all in a pack. If I now ask you, what search provider is OpenAI using? How do they do their search? You have no idea. Yeah. If you go out in the web, and then there are clever people who re-engineered everything, compared ranking lists between Google and OpenAI, and found out, oh, they're quite similar. So most likely OpenAI is using a Google search in the back end to make this first 1,000 results that they retrieve, and then they re-rank based on your profile. But we don't know. That's my biggest problem I have. I don't know.
And I was thinking now how to make it more engaging for Europe, because this is something from Europe for the Europeans. And I think to improve the engagement, it would be nice if each knows where they can stand towards this offer, because it's amazing. It's an amazing project. It's tackling a very challenging point of our society.
Yeah, thanks for that. I agree. The problem what we currently have is we missed the last step. We do not have a search API out there. I'm currently working on that, so if I go back, I'm back to coding mode, so making that. But I want to make this kind of search APIs available, and then engage with different partners, whether they want to offer that or not. One for education that is publicly curated. I'm also thinking more in this kind of Wikipedia model, not a community. A Wikipedia community has its own problems. There's a lot of problems in there. But to have at least a community process that curates this kind of information, or this kind of AI endpoints that AI systems can use. Yeah, I think so. Yeah, I cannot start. I think you need to have small, tangible use cases in order to start.
Okay, I just had a technical question for my personal curiosity. I wondered if you have run or seen the calculation, if you wanted to build a web scale dense vector embedding index, right? Like, let's say you take a 1 billion parameter model, hidden size 1024, like how many H100 GPUs would you need to handle your crawler output? Okay.
Impossible. We won't do that. You need a very smart pre-filtering step before that tells you which content is worth to be densely embedded. That's also agreement in the community. I talked to a number of players in the community, well-known ones, and that it's clear that the quality of the information is the important part, not the quantity of the information. So what we currently do is we have only for English, unfortunately, but we have a small model that runs on CPUs that gives us a quality score, and then we take the quality score and only those that hit a certain threshold we go further. We also have, for example, trigger warnings detection now in the next version of the pipeline that tells you if there are phrases or words in the web page that could trigger a certain unpleasant emotional state. So we will also exclude that. But the focus is clear on quality and small models. I still believe that small models will be much stronger in the future than large ones. There's also where I believe that the US is currently doing a large bet in that regard.
Like, is it like a million H100s? Would it be 10 billion? Like, did you actually run like calculations like that?
You have to do 100 million URLs per hour, and I guess the maximum you get through is 100 per second maximum per GPU. So it would take, I guess, the Erlangen cluster full time. Sorry, I can't do the math now in my head. After it, our talk is too much. Good question. I don't know. It sounds like a little bit of resignation, but on the tech side, I quote Renoir from Mastodon. Yeah, the tech is not the problem. We have to convince the political level and the leaderships. And if I tell you, am I still online? Okay, then I have to be polite. No, the point is we had a lot of exchanges with various different levels, and we found that it's quite hard to make people understand what we do, and it's quite hard that they not say, oh yeah, that's too big for us. Yeah? Go to the European level, and they say, oh no, you have to get the member states on board first. So you always send from one end to the other end, which is a lot of elevator driving, as my colleague puts it, in different occasions. And this is also for me a systematic problem as a smaller organization. This is done by big tech. This is done by a lot of people who want to get a certain viewpoint, certain policy decision making, and they can pay a lot of people for doing that. And it's okay to do that because politicians have to make informed decisions and you have to invest the time. But often you do not have the capacity to do that. And that is where we are currently lacking. My current, so for example, we have on the 2nd of December, we have an event in the Brussels Parliament where we have a parliamentary breakfast trying to convince a few people. We also try to get appointments with other stakeholders in Brussels to drive that forward. We are working very, very nicely together with AI factories. That's a good group. There's a lot of potential currently. So, and the topic is picked up by certain groups in politics, but you have to stay and you have to play that ball further. And there is always the risk that you lose the energy because some project ends, you need the other funding and so on and so forth. Yeah. But my current goal is to have small prototypes that are recognized, show where the value is, and then hopefully with this value convince other people to go further.
Maybe that's a good moment to kind of wrap up this evening. And I would like to add to the question of the president, maybe not everyone heard it, How can we make this a European movement? I think it's clear the first step is like, we have to believe that it needs to be a European movement. And then we have to spread the message in an academic environment, in a public environment, also in an industrial environment, because without the economic, like where is the money? The money is in the economy. So we need to convince the governments and the industry and the society, because in a democracy, we need at least the majority like to push forward to that. And so we hope that with our format, we're doing like first little steps, but we'll keep on telling the stories. I'd like to end with a quote that I heard from one of our like guests. This is a European thing for Europe, so it's also important to highlight. It's not like an academic project for the sake of academics. No, it's like because a certain group believes that this is the right thing according to our European values, and a counter model to like the purely capitalist market model that say we've seen in big data. And I'll thank our host, I'll thank you, the audience, and I'll invite every one of you for the next session in 2 weeks, where we will have another of our ITU fellow professors. And with that, let's have a lovely evening here, and thanks to everyone online. Thanks to Mika Gani.